Forget everything you thought you knew about these silent giants. Today, we're performing open-heart surgery on a transformer, piece by intricate piece. Get ready to witness the astonishing engineering that allows these devices to handle incredible amounts of electricity and learn why each component is absolutely critical to its powerful function. Have you ever walked past one of those big, gray boxes humming quietly on a utility pole or in a substation and wondered what's going on inside? They seem so simple from the outside, but they are the unsung heroes of our modern world, silently working 24/7 to power our lives. Today, we're going beyond that familiar hum. We're going to demystify this incredible piece of technology, because understanding how our electrical grid works starts right here. This isn't just about taking something apart. It's about appreciating the genius behind it. So, grab your safety glasses, and let's get ready for a deep dive you won't forget. Welcome to the workshop. Before us sits our subject for today's exploration. Disassembling a transformer isn't a brute force job. It requires surgical precision. We'll be using a specific set of tools to carefully remove each part without causing damage. The goal is to respect the engineering and understand its purpose. The first step is breaking the seal. This outer casing is more than just a box. It's the first line of defense against the elements and physical impact, protecting the delicate and powerful components within. As we unbolt the main lid, we'll get our very first glimpse of the internal architecture. It's a tightly packed world of metal, wires, and oil. Let's peel back the initial layers of casing and insulation. You can immediately see that everything is meticulously arranged. This isn't random. Every single piece has its place and its function, all designed for maximum efficiency and safety. Now, we're at the heart of the beast. With the top off, we can see the core components, and this is where the real magic happens. Let's start with the windings. See these massive spools of copper wire? These are the primary and secondary coils. One coil receives the incoming voltage, and the other sends out the transformed voltage. The ratio of the number of turns in these coils is what determines whether the voltage is stepped up or stepped down. It's a beautifully simple principle with a powerful impact. But these coils can't do it alone. They are wrapped around this central structure, the magnetic marvel known as the laminated steel core. Why is it laminated? It's made of thin, insulated steel sheets stacked together. This clever design minimizes energy loss by reducing something called eddy currents, which are unwanted circular currents that generate heat. This core's job is to concentrate the magnetic field created by the primary coil and channel it efficiently through the secondary coil. It's the superhighway for magnetic flux. Of course, with high voltage comes great responsibility, the need for serious insulation. The entire assembly is submerged in what's known as dielectric oil. This oil serves two critical purposes. It's a fantastic electrical insulator, preventing short circuits between the live components. And it's also a coolant, drawing heat away from the core and windings. In addition to the oil, you'll find solid insulation barriers, often made of special paper or pressboard, strategically placed to ensure that electricity only goes where it's supposed to. Without this multi-layered insulation system, the transformer would fail almost instantly. So, how does this functional symphony come together to perform its voltage magic? It all comes down to electromagnetic induction. When alternating current flows through the primary coil, it creates a constantly changing magnetic field in the steel core. This magnetic field, in turn, induces a voltage in the secondary coil. If the secondary coil has more wire turns than the primary, the voltage is stepped up. It has fewer turns, the voltage is stepped down. That's how power plants can send electricity over long distances at incredibly high voltages to minimize energy loss. And then local transformers can step it down to a safe level for our homes. But all this work generates a tremendous amount of heat. If not managed, this heat would destroy the transformer. That's where these external fins, or radiators, come in. The hot oil from inside circulates through these fins, where the large surface area allows the heat to dissipate into the surrounding air. On larger transformers, you might even see fans or pumps to assist with this cooling process. It's a vital system for keeping the transformer operating safely and efficiently. Beyond these basics, there are other important components. See this device on the side. This is a tap changer. It allows for small adjustments to the turns ratio, fine-tuning the output voltage to keep it stable even when the input voltage fluctuates. And these large ceramic or polymer insulators where the wires enter and exit the tank. These are called bushings. Their job is to safely conduct the high-voltage lines through the grounded metal casing of the transformer without causing a short circuit. Each auxiliary part plays a crucial role in the transformer's reliability and performance. Now that we've seen all the individual parts, let's conceptually put it all back together. Imagine the laminated core at the center. The primary and secondary windings are wrapped securely around its limbs. This entire core and coil assembly is then carefully lowered into the main tank. Insulation barriers are strategically placed. The bushings and tap changer are connected. Finally, the tank is sealed and filled with dielectric oil, completely submerging the internal components. The radiators are attached, ready to whisk away heat. When you see a transformer now, you can visualize this intricate world humming away inside. The real-world impact of this technology is staggering. Huge step-up transformers at power plants prepare electricity for its cross-country journey. Step-down transformers in substations and on utility poles make it safe for our neighborhoods and homes. And even smaller transformers are inside countless devices we use every day. From our phone chargers to our microwaves, converting the wall outlet's voltage to what the device needs. Our entire electrified society is built upon the reliable function of these devices. We've only scratched the surface today, but hopefully, this disassembly has given you a new appreciation for the engineering marvel that is the transformer. I encourage you to keep exploring, ask questions, and look at the world around you with a new sense of curiosity. There's so much incredible technology hiding in plain sight. Thank you so much for joining me on this deep dive. If you enjoyed this journey into the heart of a transformer, please give this video a thumbs up and consider subscribing to the channel for more engineering explorations. Let me know in the comments what you'd like to see us take apart next. Until then, stay curious.